In this final lesson of chapter 10, we're going to be looking at circles in the coordinate plane. We're going to be looking at their equations and how we can solve for that equation, and then we will look at some real life problems as well. So when we look at circles in a coordinate plane, their equation is going to be written in standard form right now. So this is basically standard form. It's x squared plus y squared equals r squared. This would be a circle where the center is at the origin. It's at 0, 0. But we will have ones that are going to be off-centered. And so the standard equation of a circle, whenever it changes from that center, is going to be based on the second formula, where we have x minus h squared plus y minus k squared equals r squared. And so now in this formula, the h and the k are going to represent the center of the circle. Okay, that's going to be that coordinate point of where it is. And so in this first example, we have actually two parts to it. It says write the standard equation of each circle. A says the circle shown at the left is actually to the right. I switched it. Okay, so the circle to the right on my video. So the circle in this picture, we need to look at where its center is first off. Okay, so the center of this circle, if you notice, we go all the way across, would be 1, 2, 3, 4, 5, 6, right? So the diameter here would be 6. And so at the diameter 6, that means the radius is 3, and on this, it would be 3 on each side of this. So that means the center in this case is actually going to be at 0, 0. Okay, so if we have a center at the origin, it follows our formula that we showed in the first part, okay, where we have x squared plus y squared is equal to r squared. So obviously r squared is our radius. So if we start to write that out, we have x squared plus y squared is equal to r squared. Well, when we counted that, we said it was 6 across the diameter. So the radius is half the diameter. So that means our radius would have to be 3. And so our standard equation for A would be x squared plus y squared equals 3 squared. And then we go ahead and solve what we can of the 3 squared would be 9. Okay, so here for A, this would be our answer. Okay, standard form. In our second one for B, we have a center that is at 0, 9, and then it gives us the radius of 4.2. So for this one, okay, let's look back at the problems that we had before, okay, where it showed us the formula. Okay, this lesson we are actually going to be using this formula, okay? So you need to be writing your standard equation formulas each time and then be filling them in. So we have x minus h squared, that whole thing, plus y minus k squared equals r squared. So if I write that out, I have x minus h squared plus y minus k squared is equal to r squared. Our h and k is our center, if you look back. HK is the center here. So if we label it, this is going to be h, this is going to be k, and so I just filled them in, and obviously we know our radius here is the 4.2. So we're going to plug all this in. So we have x minus our h, which is 0, plus y minus our k, in this case is a negative 9. I'm going to plug that whole part in for k. I'll worry about my negatives in a second. And then I have 4.2 in for r squared. Now I just need to simplify this. Well, x minus 0 isn't going to change any of that, so I can just get rid of my 0. So I would just have x squared plus y, and then here I have a negative times a negative gives me a positive, plus 9 squared, and I left that off up here, is equal to 4.2 squared. That one you could just put in your calculator. It's already a decimal. So it's going to give you 17.64. And then I'm just going to go ahead and simplify this one more time. I'm going to take these parentheses off the x squared here. But otherwise, the y plus 9, we're going to leave that part in parentheses. And so this is going to be our answer. Okay? Our standard equation for that circle would be x squared plus y plus 9 squared is equal to 17.64. In the second example, we are given our center. Okay, so our center, obviously, like we said a while ago, is our HK. So my negative 1, 3, I can label as HK. And then we have a point. We are going to have to actually find our radius on this circle, in which you could do it two different ways. Okay, now I will tell you the way they're wanting you to do it in this problem is they're wanting you to use distance formula. Okay, the distance between 2 points, so the distance between the center and the point on the edge, we could use distance formula, and that would give us our radius. Okay, but if you notice this circle, this edge here, if I follow the straight line, is on the edge of the circle right there, is on an exact point. So in this circle, I can actually just count the radius. So I would have 1, 2, 3, 4, and 5. So all we're doing is just plugging this in again. So our formula of x minus h squared plus y minus k squared is equal to r squared. And this is on your formula charts. If you want to grab one whenever you're taking quizzes and tests, then just grab a formula chart and it's on there. And so now we just need to plug it in. So my x minus h, now I have a negative 1 in for that h. Y minus my k, which is 3, is equal to r squared. We just said that r, if we counted over here, was 5. So that would be 5 squared. Then I'm just going to simplify it. So I have x, I have a negative times a negative, makes a positive. So x plus 1 squared plus y minus 3 squared is equal to 5 squared, which is 25. So our equation is going to be that one right there. X plus 1 squared plus y minus 3 squared is equal to 25. In this last example, we're just going to kind of briefly look over it. It's just a cool example of how they actually use this in real life. Whenever they're doing earthquakes, they try to find where it originates, the epicenter, where it started at. And so it's just kind of cool how they use circles actually from their different, what they're called, the seismographs is what it says. But basically the sensors that they put out to register these things, then they can actually figure out and pinpoint where it originated at. Probably with very good accuracy, I would imagine. Especially with today's technology. And so this first one, like, it's just telling you the epicenter, like they can tell how far away it is. So they're saying the epicenter is 7 miles away from A, negative 2.5. So that's the location of these seismographs. So if we look at a graph, and I just have graph paper here, and so I'm just going to draw basically our x and y axis a little bit here. And like I said, this is going to be kind of approximate. And so we have A at negative 2.5. So if I go negative 2 and up about 2.5, there would be approximately the A sensor. B is at 4, 6. So 1, 2, 3, 4, 6 would be B. And then C is at 3, negative 2.5. So it would be about right there. And then it tells us how far the epicenter is away from each one. So it actually measures the distance. So basically what we would do here is we would try to draw a circle that's approximately has that radius, okay, for how far the epicenter is. We know it's 7 miles away, so we know it's going to be inside that radius somewhere of A. So if we count out 7 from A, we would go 1, 2, 3, 4, 5, 6, 7. Okay, and we're just going to kind of draw some other points to make a circle. Okay, so something like this would be approximately, now it would actually be a little bit further up. So we would have a circle somehow with an arc going this way, right? It's not, like I said, we're approximating this. My circle obviously is not beautiful there. But we would have this circle going all the way around A with a radius of 7. Okay, so then we would need to do the same thing for the other one. So B, the epicenter is about 4 miles away. So we count around it. 1, 2, 3, 4. 1, 2, 3, 4. and we kind of draw a circle going through it, we would have this circle around B. And then C, same thing. We go 1, 2, 3, 4, 5, going all the way around. Until we have another circle approximately. And so if we know that all 3 points of this, we know that the epicenter of this earthquake is somewhere on these circles, then it would happen where all 3 circles intersect. So you can tell even from my very vague drawings of circles, we have an approximation right here. And so that point we could count and be 1, 2, 3, 4, 5, 1, 2 would be approximately 5, 2 would be the location of where this earthquake originates. And like I said, we could go through specific calculations trying to do that, but actually if you go through them, you would still get 5, 2. And so just drawing it gives us a pretty good approximation of where it would be located.